Today, we're diving into server-side development, a crucial aspect of building robust and interactive web applications. This is all about creating the invisible backbone that powers dynamic web applications and ensures their smooth operation. Let's explore the core functions of server-side scripting, which are essential for any modern web application. These functions are vital for enabling dynamic and secure web interactions, making your applications responsive and safe. First, server-side scripting allows us to generate dynamic content, adapting responses based on various factors. This means generating HTML, JSON, or other responses that change based on user input or specific data requests. Another key function is database interaction, which is fundamental for managing application data effectively. Here, the server retrieves, stores, and manipulates data, ensuring persistent and organized information for your application. Server-side scripting also handles authentication and authorization, crucial for securing user access. This includes managing user logins, maintaining sessions, and implementing robust access control mechanisms for security. Finally, it enables secure transactions, protecting sensitive operations performed by your users online. Such operations include processing payments or encrypting sensitive data, ensuring confidentiality and integrity. Now, let's take a quick look at Node.js and PHP, two popular choices for server-side development. We'll highlight their key differences in server-side scripting, helping you understand when to use each. We'll compare them across several important aspects to give you a clear overview. First, let's consider the programming language each technology primarily utilizes for development. Next, we'll examine their concurrency models, which dictate how they handle multiple requests simultaneously. Then, we'll look at the types of database support each offers, influencing your data storage choices. We'll also compare their performance characteristics, especially for different kinds of web applications. Consider the ease of learning for beginners, which can be a significant factor for new developers. Finally, we'll discuss their typical use cases, helping you decide which is best for your project. Let's begin by looking at Node.js and its specific characteristics across these aspects. Node.js uses JavaScript, a very popular language for both front-end and back-end development. Its concurrency model is event-driven and non-blocking, making it efficient for I/O-heavy applications. Node.js offers excellent database support for both NoSQL databases like MongoDB and traditional SQL databases. It delivers high performance, particularly well-suited for real-time applications requiring quick responses. While powerful, Node.js can be moderately challenging for beginners due to its asynchronous nature. Node.js excels in real-time applications, building APIs and single-page applications efficiently. Now, let's turn our attention to PHP and its distinct features for server-side development. PHP, of course, uses the PHP language itself, widely known for web development. PHP typically uses a multi-threaded, blocking concurrency model, handling requests sequentially. It primarily supports SQL databases like MySQL and PostgreSQL, which are staples for many web projects. PHP offers good performance, especially for traditional web applications and content management systems. It is often considered easier for beginners to learn, with a straightforward and intuitive syntax. PHP is widely used for content management systems, e-commerce platforms, and blogging websites. Let's get practical now and learn how to build a very basic Node.js server from scratch. We'll walk through the essential steps required to get your very first Node.js server up and running. First, ensure Node.js is installed on your system, then verify the installation using simple commands. You can check your Node.js and NPM versions by typing node-v and npm-v in your terminal. Next, we'll create a simple HTTP server using Node.js's powerful built-in HTTP module. This line imports the HTTP module, giving us the tools to create a web server. Now, we define the server's logic for handling incoming requests and crafting appropriate responses. This code creates a server that responds with Hello, Node.js for every incoming request, setting the content type. Finally, we start the server and instruct it to listen for connections on a designated network port. This command starts the server on port 3000 and logs a confirmation message to your console, indicating it's active. Let's now explore the fundamental pillars that guide the design of effective RESTful APIs, which are crucial for web services. These core principles are essential for building scalable, maintainable, and robust web services that work efficiently. Our first pillar is resource identification, focusing on how we uniquely identify everything in our API. Always use nouns in your API endpoints, like /users or /products, to represent resources clearly. Next, we have HTTP methods, which define the actions you can perform on these identified resources. Leverage standard HTTP verbs such as GET, POST, PUT, and DELETE to specify the intended action for each request. The third pillar emphasizes stateless interactions, meaning each request should be independent and self-contained. This ensures that every request contains all the necessary information without relying on previous server-side sessions. Then, we focus on the URI structure, which dictates how your URLs are organized and presented. Use hierarchical and meaningful uniform resource locators, or URLs, to provide clarity and predictability for API consumers. Finally, we consider HTTP status codes, which communicate the outcome of an API request. Always return appropriate status codes to clearly indicate whether a request succeeded, failed, or requires further action. Now, let's dive into implementing RESTful APIs using Node.js, a popular server-side runtime environment. We will build a simple user management API using Express.js, a fast and minimalist web framework for Node.js. First, let's set up our server and define some initial data for our API to work with. The Express module creates our web server, and Body Parser helps process incoming request data. A mock users array simulates a database. This code sets up an Express server, configures it to parse JSON, and initializes a simple array to act as our user data store. Next, we'll implement routes to handle GET requests for retrieving data and POST requests for creating new resources. The app get method fetches resources, either all users or a specific user by ID. The app post method creates a new user. Here, we define routes to fetch all users, retrieve a user by their ID, and create a new user via a POST request. Let's explore the key functions that a web server performs, which are vital for any web application. These essential roles ensure the smooth and efficient delivery of web applications to users worldwide. One crucial function is static content delivery, serving files like HTML, CSS, and images directly. Web servers also handle dynamic content, processing requests to generate personalized content on the fly. Another key role is request routing, directing incoming requests to the correct application components. Many web servers perform load balancing, distributing network traffic efficiently across multiple backend servers. Finally, security is paramount, with servers implementing measures like SSL/TLS to protect data transmission. Let's walk through the typical user authentication process, a critical security mechanism for web applications. The process begins with user login, where a user provides their credentials, typically a username and password. Next, server validation occurs, where the server verifies the provided credentials against its stored user data. Upon successful validation, the server proceeds with token issuance, generating a unique token for the authenticated user. Finally, for subsequent requests, the user includes this token, allowing the server to verify their identity without re-login. All right, let's now bring everything together with a quick summary of what we've covered in server-side development. These are the crucial key takeaways that you should remember from our deep dive into server-side development concepts. Server-side scripting is essential for generating dynamic content and managing backend logic, using technologies like Node, JS, and PHP. RESTful APIs enable structured communication between different systems, leveraging standard HTTP methods and resource-based principles. Web servers, such as Apache and Nginx, are fundamental for delivering web content, routing requests, and ensuring security. Remember, authentication verifies a user's identity, while authorization precisely controls their access to specific resources. Session management and cookies are vital for maintaining user state, despite the inherently stateless nature of HTTP requests. And finally, secure coding practices are absolutely vital and must be implemented across all layers of server-side development.